Of yesterday, and I don't like this name here, fractional, no. We worked yesterday with rational exponents. The concept, the definition of A exponent m over n. Okay, this is what we worked yesterday. And the summarizing is this. If you have A exponent m over n, you can rewrite, you can make it equal to, then write parentheses, okay? Inside the parentheses, you're gonna write a root. The index of this root is the denominator n, so this is the index, and the power outside the parenthesis is the numerator m, and here inside the root you're going to have the same as the base, say a. So you can rewrite, and from this point you can simplify. You can calculate what is the nth root of a, then you can calculate what is the, after you find the result, what is this result to the power of m, and you're going to be able to simplify the expression. Let me check if you understood how to apply this thing, okay? We're gonna have a quick check now on the next slides. You are all ready? Now, answer to me. What is the value after the simplification of letter A? What is the value that we find after the simplification for letter B? And what is the value after you do the simplification of letter C? Type on the chat, send me your messages, send me your answers. So after you do the last step is to submit the number to the power, right? So the first steps are done here. Again, just to make sure you understand, and this last one. The denominator is the index of the root, right? The numerator is the power outside the parentheses. So you move to this second step, calculate inside the parentheses the result. The fourth root of 81 is 3. So you go to the next step. Now we're going to apply the exponent 3. 3 to the power of 3 is equals to 27. Okay? Any questions about this review? As long as you understand what you're doing, if you remember the definition we have seen before, again, this is the definition, that thing. If you remember this, apply and simplify, just calculate step by step. Okay? Moving on, because today we have a new, it's not a new topic, to be honest. It's the next topic of our chapter 6 that we are working on. The next topic is about properties of rational exponents, and those properties are the same properties that we have seen before in chapter 4 on working with exponents. Check this out. We will apply again to rational exponents, but we have property number 1. If you find a multiplication of like bases, if you have the same base, like base A, multiplied with different exponents, you have to add the exponents, right? Division of like bases. If you have this, the division and the base is the same, you have to subtract exponents. And the power rule, and if you have something like that, the base with an exponent and then parentheses another exponent outside, you're going to multiply the exponents. Number 4, power of a product, and this, if you have a product with the two different factors to the same power, you can apply, it looks like a distributive property. You're going to distribute this exponent to each factor. And the power of a quotient is kind of the same thing, because you're going to apply, they're going to distribute this exponent for each factor, numerator and denominator, and those are the power of a product and the power of a quotient. All right? We have worked with this table before on chapter 4. We will work again on applying to rational exponents. Today we're gonna go back to this table a lot during the quiz. And there are a few other properties that this is old stuff, but maybe you will remember. A exponent negative m, you can change, you can write, you can flip, right? Is equals to 1 over a exponent m. And if you have a is different from 0. A needs to be different from 0. A exponent 0 equals to 1. Any number or expression different from 0, if you submit to the power of 0, is equals to 1. And let's apply to a few examples, okay? Let's try to remember how to use this table, those properties, on a few examples. And we have here letter A. Let me write down again, letter A. Y exponent 2 over 5 times y exponent 3 over 5 equals, what is this? Check the table. Look on the properties. What kind of property you will use? You are going to apply. And this is definitely a multiplication of like bases, and we're going to use this property here. We will add the exponents, right? So let's go back. And we need to add the exponents. So this is equals to y, 2 over 5 plus 3 over 5. This is y, 2 plus 3, 5 over 5. This is equals just y. That is the right answer. Just y. Good, because we've checked the table and we look at it is a multiplication of like bases. We have to add the exponents. Now let's check letter B. Letter B is another situation. On letter B, let me rewrite this here at the bottom. Letter B. Now we have 6 times a exponent negative 1 over 2 over a exponent what? 3 over 2. What kind of property should we apply now? Go back to the table, check what kind of property is this, and this is a division of like bases. We will apply this one. We need to subtract the exponents. So let's move. Let's work on the subtraction of those exponents. 6, you just keep the 6 as it is, and we have a is the like base, right? A is the like base. A, the exponent of the numerator you keep here, and then you're going to subtract by the exponent of the denominator. Agree? This is equals. Repeat the 6, then you have a, negative 1 over 2 minus 3 over 2 is negative 4 over 2. And this is equals to negative 4 divided by 2 is negative 2. Usually we don't want negative exponents. We can rewrite this using one of the other properties, the property of the negative exponent that you can flip, remember? 6 over a squared. You can flip this because it has a negative exponent, so you can rewrite this as equals to 1 over a squared. Any questions? That's it. Look, that's it. Tell me if you have any questions. I think, let me zoom out and show the whole thing to you. Tell me if you understand how to apply the properties. We will also apply multiplication. This letter C is a multiplication, is the property, is the power of a product. Okay, letter C. But you're gonna work on the quiz. We will find an example like this on the quiz and we can work together. I think we rather have more time to work together, and you can ask questions. We can develop this on the practice round, okay, during the quiz. You all agree? Should we move on? Tell me if you have any questions so we can start the quiz. No questions, comments? Right, thank you, Kiara. Thank you for the feedback. But before moving and going to the practice, tell me, what do you think is going to be the right answer for this bell work? You have the happy face, you have the sad face. What is the value of the happy face? If you can guess the numbers and check if it fulfills the conditions. Or you can try to apply a system of linear equations. You're going to say the happy face. Let me just zoom out a little bit. Let's say the happy face is x, the sad face is y. So y, x and y. You can rewrite these as equations. X plus y equals 13. Y times x equals 42. And x minus y equals 1. Okay? You have 3 equations, you just have 2 variables. You have too many equations. You actually just need, usually, you just need 2 equations to find the answer, usually. So maybe we can erase one of the equations and select the 2 equations that makes more sense to work with. I'm gonna erase this in the middle because we can apply addition methods and we can add those 2 equations. That means 2x positive y minus y 0 equals to 13 plus 1, 14. 2x equals 14. That means x equals 14 divided by 2. X equals 7. I think 7 is going to be the right answer, but we need to check, right? If 7 is x, y is equals to 6. You plug in any of the equations, you find y equals to 6. 7 plus 6 equals 13. That's right, okay. 7 times 6, or 6 times 7 equals 42. Okay. And 7 minus 6 equals 1. Okay, that's right. That's it. 7 is the right answer. You all got it right. The quiz is about simplifying expressions using the properties of exponents. Okay? Write the final answer using only positive exponents. Only positive exponents. Okay? No negative exponents allowed. Let's try letter A. Letter A, what are we working with here? And check. X, exponents 1 over 4 times x to the power of negative 5 over 4. This is a multiplication, right? So check the table of properties. Let me get back to the table of properties. It is here. Multiplying like bases, what should we do? We should add the exponents. So go back to the quiz. We will add exponents. So it's x, the like base is x, exponent 1 over 4 minus 5 over 4. That means x, this is equals to x, 1 over 4 minus 5 over 4 equals negative 4 over 4, right? And that means this x negative 1. X to the power of negative 1. But we have seen no negative exponents allowed, only positive. We can apply another property, is this one. Negative exponents, we can flip and change the exponent to positive. So flip 1 over x, the exponent is going to be positive 1, we don't need to represent, that is the right answer. All right, that's letter A. I'm going to ask you 1 minute to check attendance, and then I will get back. We can work together in all questions if you need, okay? Any questions of the quiz, or even all questions if you need. Letter M. This is, you have an expression here, lots of factors submitted to an exponent, right? And check, the property that you're going to use is the power of a product. Where you have factors submitted to an exponent, you're going to work, looks like a distributive property, that you're going to distribute the exponent to each factor. That's what we're going to do on letter M. So let me write down here. So get these exponents, and you're going to distribute to each one of the factors. You're going to multiply by the power of each factor. So first, let's start with 5. 5 doesn't have any exponents, so it's 5 squared. Now A, 2 times 2. C, negative 1 over 2 times 2. And D, 1 over 2 times 2. Okay? So you multiply each exponent from each factor to the one exponent that's outside the parentheses. 5 squared is 25. A to the power of 2 times 2, a to the 4. C, negative 1 over 2 times 2, negative 1. And D, negative 1, not negative, 1 over 2 times 2 is just 1. We don't need to write 1. Let me write just so you can remember. Remember, no negative exponents allowed. So we will change this. We will flip C negative 1, C to the power of negative 1 is equals to 1 over C. So 25, A to the 4th. D, you don't need to represent power of 1, right? Over C. That is the final answer. The simplest, the final simplified answer. Letter M. Now letter N. Thank you, Chiara. Letter N is another multiplication. Multiplication is the power rule. So we will distribute this to each factor. Starting with 2 exponent 3 times x negative 1 over 3 times 3 times y 2 times 3 times z 5 over 3 times 3. Okay? 2 exponent 3 is 8, right? 2 times 2, 4 times 2, 8. X negative 1 over 3 times 3, negative 1. Y 2 times 3, 6. Z 5 over 3 times 3, 5. No negative exponents allowed. So equals 8y6 z5 over x. Thank you, Kiara. Let me show, since I'm here, let me show letter O, which is another situation. You have the other property, which is the power of a quotient, okay? It looks the same thing. You have an exponent, you have to distribute the exponent to the numerator and the denominator. Let me just show, since we are here working together, and we have 12, I have to distribute to the numerator and the denominator. So it's going to be x negative 2 over 3 times 12 over y negative 3 over 4 times 12. See? Equals x negative 2 over 3 times 12. 12 divided by 3, 4. 4 times 2, 8. So negative 8 over, and y, negative 3 over 4 times 12. 12 divided by 4, 3. 3 times 3, 9. Negative 9. But no negative exponents allowed. We need to flip. And this is going to be interesting because we will flip the numerator to the denominator with a positive exponent. We'll flip the denominator to the numerator with the positive exponents. That is the right answer. All right. Let me zoom out.